Hello, so welcome back to another video. So today's video is a little bit different. It's not my usual prompting guide, but today I will teach you a free course about infinite prompting. So this is the first part of the course, which I'll introduce you to infinite prompting. So course overview. This free course introduces a breakthrough prompting technique that flips the script on how you'll collaborate with AI. I'm talking about prompts that evolve on their own and generate results far better than what human written prompts could do, often 10x better without needing constant input from humans. So this is a skill set I think most people don't even know exists yet. And by the end of this course, you'll be one of the few AI pioneers who truly get it. So this is what I'll cover in this first part of the course. So what is infinite prompting? Why infinite prompting? Why should you pay attention? Is this course right for you? An example prompt you can play around with. How infinite prompting follows a similar concept found in key academic research and theoretical works, and also how infinite prompting is aligned with historical context and related fields. So before I move on with the course, if you prefer to learn by reading, I have written 3 articles about this course within 3 parts of this course in my newsletter. Link in the description. Don't worry, it's free. But if the link in the description doesn't work, you can go to my channel homepage and click here and then choose free newsletter. So let's get back to the course. Okay, so what is infinite prompting? So this is a neuron. It is found in our brain. This is neural network. So first you have to know what a neural network is. So neural networks are basically the brains behind AI like ChatGPT. They are inspired by how the human brain works, well, with tons of interconnected neurons that pass signals to each other. So through training these neural networks learn to recognize patterns such as grammar, understand language, and generate responses, just like how our neurons develop and get stronger through training. So infinite prompting is inspired by neural networks and the way we learn. So instead of just giving it one shot instruction, one shot prompt, like write me an email or summarize this video. So infinite prompting, we are letting the AI think for itself and self-improve its instructions and answers to produce more intelligent answers. Just like how human learn by practice many times improve. So this is traditional prompting. So you give a prompt, the AI will think, and then the AI will give answer, and that's it. But infinite prompting, you give prompt, the AI will think, the AI will give answer, and then it will evaluate the answer and the prompt by itself. And this is a recurring loop where every loop, the instruction and the answer will get better without any human input. It's all AI. So traditional prompting is manually engineered. So infinite prompting is semi or fully automated. So why infinite prompting? So there are 4 related reasons, related phenomena, or related facts or theories about infinite prompting. So the first one is Richard Sutton's The Beetle Lesson essay. The DeepSeek R10 model. Naval's it's not 10,000 hours, it's 10,000 iterations to it. And also the complexity theory and emergent behavior. So this is Richard Sutton, one of the most recognized AI pioneer. So he wrote one of the most important essays on AI. It's called The Beetle Lesson. So the biggest lesson that can be read from 70 years of AI research is that general methods that leverage computation are ultimately the most effective and by a large margin. So basically what Richard Sutton want to tell you is that it's about how AI researchers keep wanting to incorporate human ideas to make the AI smarter. But what actually works best is giving the AI lots of processing power and letting it learn independently from massive amounts of data without human interference. So there were many examples of AI researchers related learning of this Beetle lesson, and it is instructive to review some of the most prominent. So there are several examples that demonstrate Richard Sutton's Beetle lesson. The first one is chess computers. So people tried to teach computers chess strategy, But what actually beat the world champion was a computer that could calculate tons of possible moves on its own really fast. So think about IBM's Deep Blue versus Gary Kasparov. The second is Go computers. Same story as the chess. Researchers spent 20 years trying to make computers understand Go like humans do. But humans were eventually beaten by computers that just practice against themselves millions of times. So think about DeepMind's AlphaGo versus the Sedol. Another one is speech recognition. So people tried to program in knowledge about words and sounds. But what worked better was just letting computers listen to lots and lots of people talking. And the last one is computer vision. So early researchers tried to teach computers to recognize specific shapes and features. But now we have found that showing them millions of images and letting them figure it out themselves work better. So why this matters? Why is this revolutionary? So the beta lesson suggests that in the long run, the most powerful prompts won't come from humans. They will be built by AI itself, using stronger and better methods baked in from the start. So let's move on to the second reason, the DeepSeek R10 model. So basically, DeepSeek discovered its new model having an aha moment, where it developed an advanced problem-solving technique entirely on its own. So during this phase, DeepSeek R10 learns to allocate more thinking time to a problem by re-evaluating its initial approach. So this is a captivating example of how reinforcement learning can lead to unexpected and sophisticated outcomes. So the results is it underscores the power and beauty of reinforcement learning rather than explicitly teaching the model on how to solve a problem. So it autonomously develops advanced problem-solving strategies. So this is a powerful reminder of the potential of reinforcement learning to unlock new levels of intelligence in artificial systems. So there was a group of researchers who created this chart to show how the accuracy, the blue line, improves as the model goes through more steps of reinforcement learning. So as you can see, the more training steps of reinforcement learning, meaning the more loop the AI goes, the higher the accuracy, the higher the answers, the better the answers. Okay, to understand why this is a big deal, so think back to IBM's Deep Blue versus Gary Kasparov and DeepMind's AlphaGo versus Lee Sedol. So actually during one of the chess games, Kasparov noticed a new unfathomable strategy move by Deep Blue that eventually led to his loss. And also AlphaGo made several moves that human never thought of, which stunned human experts and Lee Sedol himself. So R1 did something similar. So its development of advanced problem-solving strategies through learning over and over again is a really big step in AI's capacity for independent learning. So these three suggest that AI are capable of coming up with novel and unexpected approaches that humans haven't thought of or explicitly programmed. So why this matters? Why is this revolutionary? So one of the goals of infinite prompting is to get high quality, novel answers with each iteration. So I believe there's a whole world of original, undiscovered, useful and universal ideas still out there. And I think a technique like infinite prompting could be the key to unlocking them. So the third reason, the third whys of infinite prompting is Naval's tweet. It's not 10,000 hours, it's 10,000 iterations. So this line connects so well with what we've discussed above, with what we've discussed before this. So if you don't know Naval, he's an icon of Silicon Valley and startup culture. So he's also an early investor in Uber, Twitter, Notion, and much more. And much more startups. So let's move on to the fourth why. So complexity theory and emergent behavior. So the core idea behind complexity theory and emergent behavior is that all the complexity we see in the world might actually stem from a few super simple rules, just iterated and repeated over time. So for example, zygote to human. So you start as one cell, simple rules. The cells divide, the cells interact, and then self-organize. Then suddenly, a fully formed human with thoughts, emotions, abilities is created just from a simple cell divide. Another one is spark to forest fire. So one spark hits fuel and then get influenced by wind and terrain So repeated over and over again, the fire spreads fast. And what started tiny becomes a massive wildfire, destroying habitats and ecosystems. So another one is AI chess player. So it's like what we've discussed before about Deep Blue and Gary Kasparov. So AI learns basic rules, yeah, and then plays itself repeatedly. And then feedback from wins and losses improve strategy. So eventually it makes genius move no one thought of. So why is this? Why this matters and why is this revolutionary? So you could start with a simple prompt that produces a simple output. Then it self-iterates over and over again till it creates a complex prompt that generates mind-blowing results and unexpected ripple effects in the real world. So this is what infinite prompting is about. So now let's move on to why should you pay attention to infinite prompting. So the first one is AI just came into the picture 3 years ago. ChatGPT was released in 2022. So and we are going to be using ChatGPT or any other AI for decades. So what are the chances we figure out all the best approaches in the first 3 years? So if you ask me, it's pretty low. But the second is it's not mainstream yet, so that means you've got the chance to be one of the AI pioneers or frontrunners. And the third one, it's durable because instead of spending time making perfect prompt that might get outdated by new updates to the AI models. So infinite prompting actually make things better when new models come out because infinite prompting is equals to the AI self-learning itself. So the first one is high leverage because the power to get incredible results from a simple prompt could completely change the way we use AI. The fifth one is you could use it in every situation. So with infinite prompting, you could discover new marketing strategies. You could generate more breakthrough ideas within your domain. You could discover new arguments about the topic. You could generate new styles for arts, music, and even find new scientific hypotheses. So the possibilities with infinite prompting are endless. The last one is get out of your own box. So infinite prompting will stretch your thinking into territories you've never even considered before. Because infinite prompting is used to find new, novel, breakthrough ideas. So is this course right for you? If you've already got the basics of prompting down, and you're ready to level up and sharpen your edge in one of the most important skills of the future, and if you want to see what's truly possible with AI, so you can be ahead of the curve and actually be ready for the future, yes, this is for you. Okay, so this is the example prompt I told you earlier. So you can get this prompt and the link to the research papers in my free newsletter. So the link to my free newsletter is in the description. If the link does not work, go to my YouTube homepage and find the link there. Now let's move on to the next part, which is how infinite prompting follows a similar concept found in key academic research and theoretical works. So the first one is zero reasoner, a research from 2025 this year. So this research introduces a fresh method for training AI to tackle reasoning problems in coding and math problem without needing human input. So basically, instead of using traditional techniques, which depend on lots of human created data, absolute zero reasoner or AZR takes a self-play approach. So the model first creates its own problems and then the model solves them and after that learns from the feedback it gets. So you see, despite being trained entirely without external data, AZR achieves overall SOTA performance on coding and mathematical reasoning tasks, outperforming existing zero setting models that rely on tens of thousands of in-domain human-created examples. So basically, the models outperform another model that is trained with human-created data. So this might just change the game for how we might prompt in the future because AZR achieves its performance level without ever having access to expert created human data for training, unlike the models it surpassed. So another one is Prompt Breeder from 2023. So prompt reader is instead of manually writing prompts, prompt reader uses an LLM, specifically Palm 2L, to evolve the prompts on its own. So prompt reader works with two types of prompt. The first one is task prompt, where the prompt tells the model what task to do, and the other is mutation prompt, where the prompt tells the model how to improve those prompts. So the process is self-referential and runs in loops, improving both the task and the way improvements are made. So the result, so how it performs is prompt reader outperforms the state-of-the-art prompt strategies such as chain of thought and plan and solve prompting on commonly used arithmetic and common sense reasoning benchmarks. So basically it outperforms other top prompting strategies such as chain of thought, plan and solve, zero shot chain of thought, program of thoughts, auto chain of thoughts, OPRO, and APE. The other research is self-refined. So self-refined lets an LLM revise its own output by giving itself feedback. So basically first it generates an answer, then it critiques what it just wrote, then it uses the critique to rewrite the output. So this loop runs multiple times and doesn't require any extra training data or human supervision. So how it performs? So across all evaluated tasks, outputs generated with self-refined are preferred by humans and automatic metrics over those generated with the same LLM using conventional one-step generation. And the last one is theoretical foundations. So a lot of today's research actually builds on older ideas about self-improving AI. Back in the 90s, Jürgen Schmidhuber, if any German is listening to this, I'm sorry if I mispronounce the name. So Jürgen Schmidhuber and others were already talking about systems that could tweak themselves to get better over time. And the idea goes even further back, like Irvine John Good's Intelligent Explosion from 1965, where an AI keeps redesigning itself to become smarter. The last part for the first part of this course is how infinite prompting aligns with historical context and related fields. So there are four historical contexts and related fields. But the first one is biological evolution, genetic programming, self-modifying code in AI, cellular automata, and also strange loops. These are long to explain, so I don't want to make the video any longer. So if you're interested to read this, you can go to my newsletter. The link is in the description. But if the link does not work, you can go to my YouTube homepage and click here. So it will direct you to my homepage, and also you will get this, and you got to read this. So that's all from me. Thank you.